Welcome to episode 45, the Zero Trust Security Model, where we explore one of the most important evolutions in cybersecurity thinking. Traditional defenses once relied on the idea of a trusted internal network surrounded by a strong perimeter. But as organizations moved to cloud services and remote work, that model collapsed. The new approach assumes that breaches can happen at any moment and that trust must never be granted automatically. In Zero Trust, every access attempt, whether from inside or outside, is verified, validated, and continually monitored. This episode explains how Zero Trust shifts focus from network walls to identity, data, and device integrity. It's not a single product or technology, but a comprehensive philosophy that drives resilient, adaptive defense in a connected world. At the heart of Zero Trust are two defining principles: least privilege and explicit verification. Least privilege ensures that every account, device, and process operates with only the access strictly necessary for its role. Explicit verification requires continuous authentication and authorization for every action, no matter how routine. These principles eliminate blind spots where attackers often hide after gaining initial access. By reducing implicit trust and minimizing exposure, organizations gain visibility into who is doing what and why. Together, these ideas shift security from being reactive to proactive, preventing small compromises from escalating into full-scale incidents. Zero Trust transforms access from a single checkpoint into an ongoing cycle of validation. Strong identity assurance and device health validation are the foundation of Zero Trust. Since every user and machine must authenticate constantly, identity becomes the new perimeter. Multi-factor authentication, passwordless sign-ins, and conditional access all ensure that users are who they claim to be. Device compliance adds another layer, confirming that the hardware requesting access is patched, encrypted, and managed. For example, a device that fails compliance checks might still connect to the internet but cannot reach sensitive resources until fixed. By tying access decisions to both user identity and device state, Zero Trust eliminates the false comfort of a trusted network and replaces it with real-time trustworthiness. Microsegmentation and network containment address how to prevent attackers from moving laterally once inside. Instead of treating the network as a single open space, Zero Trust divides it into smaller zones with strict access boundaries. Each workload, application, or service communicates only through authorized channels, often mediated by identity-aware gateways. If one segment is compromised, others remain isolated, dramatically reducing impact. This concept mirrors the idea of watertight compartments in ship design. One breach does not sink the entire vessel. Microsegmentation requires detailed mapping of dependencies and access patterns, but rewards organizations with resilience against stealthy intrusions and insider misuse. Applications in a Zero Trust model are accessed through secure brokers that enforce policy at every request. In Microsoft's environment, this often means access mediated by services like Azure AD Application Proxy or Microsoft Defender for cloud apps. These brokers act as intermediaries between users and apps, verifying identity, inspecting traffic, and applying session controls before forwarding data. This approach ensures that applications never directly expose internal endpoints. It also supports monitoring, conditional rules, and data loss prevention in real time. By filtering every connection through an intelligent broker, Zero Trust ensures that application access remains both seamless for legitimate users and sealed off from unverified sources. Data classification and protection extends Zero Trust principles to the information itself. The model assumes that sensitive data can appear anywhere, on devices, in emails, within cloud storage, or inside applications. Classification tags, encryption, and rights management help enforce protection wherever data travels. For instance, a document labeled confidential might automatically restrict sharing outside the organization or require encryption before being emailed. This data-centric approach recognizes that breaches often bypass technical boundaries. Protecting the information, not just the system, means security travels with the asset rather than relying solely on its environment. It transforms security from a place-based model to an attribute-based one. Continuous monitoring and risk evaluation make Zero Trust an active, living defense system. Instead of relying on one-time audits or static alerts, telemetry feeds from identities, devices, and applications are constantly analyzed for anomalies. Machine learning models detect deviations from normal behavior, such as a sudden sign-in from a new location or an unusual data download. This visibility enables rapid detection and containment of threats before they cause harm. Continuous monitoring also supports compliance, generating a clear record of who accessed what and when. In Zero Trust, observation and analysis never stop. They are as integral to defense as firewalls or encryption. Automation plays a central role in making Zero Trust practical at scale. Policy enforcement and response actions must occur in seconds, not hours. Automated systems can block risky sessions, require additional authentication, or isolate compromised devices without human intervention. For example, when a sign-in risk score spikes, conditional access might automatically require multi-factor verification or deny access. This automation reduces the human bottleneck and allows security teams to focus on strategy rather than repetitive tasks. The goal is to move from reactive firefighting to proactive orchestration, where technology enforces consistent policy across the entire environment. Replacing traditional perimeters with identity-centric controls redefines how organizations think about protection. Instead of securing network edges, Zero Trust secures every transaction, connection, and user interaction. Identity becomes the control plane, governing access to data, devices, and services based on continuous verification. This identity-centric approach supports hybrid and cloud environments equally well, because it follows users rather than physical infrastructure. It also simplifies collaboration with external partners and devices, since access can be safely extended without expanding the trusted network. In essence, Zero Trust shifts defense from geography to logic security, based on who and what, not where. Aligning Zero Trust with Azure capabilities brings theory into action. Microsoft's cloud platform includes native tools that implement each pillar of the model. Microsoft Entra handles identity. Defender for Endpoint and Intune manage device health. Defender for Cloud Apps governs data access. And Sentinel provides analytics and automation. Azure also supports microsegmentation through network security groups and private link services. These components integrate through shared telemetry and policy frameworks, giving administrators a unified control surface. Rather than reinventing security architecture, organizations can map Zero Trust principles onto these existing services, accelerating adoption while maintaining consistency. Adopting Zero Trust is a journey, not a switch, and the maturity roadmap guides incremental progress. Early stages focus on identity hardening, enforcing MFA, improving sign-in monitoring, and aligning permissions with least privilege. Mid-stages emphasize device compliance, network segmentation, and app governance. Advanced maturity introduces automation, continuous analytics, and full policy integration across workloads. By treating Zero Trust as a long-term transformation, organizations can build capability gradually without disrupting productivity. This roadmap encourages measurable improvement rather than abstract ambition, proving that security maturity grows through steady practice and evaluation. Even with strong intent, common pitfalls can undermine Zero Trust efforts. One mistake is focusing too narrowly on technology while neglecting policy and process. Others include ignoring legacy systems that still rely on implicit trust, or failing to update conditional access rules as business needs evolve. Overcomplicating the rollout can also slow adoption. Zero Trust thrives on clarity and consistency. Anti-patterns such as excessive MFA prompts or fragmented identity systems erode user confidence and create backdoor workarounds. Recognizing these traps early allows teams to design sustainable, user-friendly implementations that maintain security without adding friction. Setting realistic milestones helps organizations turn Zero Trust from aspiration into reality. Foundational progress might include enforcing MFA, enabling device compliance, and monitoring privileged accounts. Later milestones can add automated remediation, data labeling, and cross-cloud integration. The key is measurable, incremental improvement, each step increasing visibility and control. Leaders should define what success looks like at every stage, from reduced lateral movement to faster incident response. This steady approach makes Zero Trust achievable for organizations of any size or sector, turning a complex philosophy into tangible, operational security gains. The Zero Trust model redefines the modern security posture as one that is continuously verified, never assumed. It merges strong identity, device assurance, data protection, and automation into a cohesive defense strategy. Every access decision becomes a moment to validate trust. Every signal contributes to context, and every action is logged for accountability. By aligning technology and culture to these principles, organizations create environments resilient to both external attacks and internal mistakes. Zero Trust is not a destination, but a discipline, an ongoing commitment to questioning assumptions, validating trust, and strengthening security with every interaction.